My interpretation of the problem is to approach it as part of a framework, and this is mainly to deliver a declarative solution, a declarative programming solution, which I believe is much clearer, comprehensible, maintainable, and modifiable, even by non-programmers. So I won't go into detail about the framework. There's plenty of documentation on a GitHub wiki that I've given a link to. I've bundled together all of the declarative code for my example and services. The framework itself is Angular. It's written in ES6 and uses JavaScript classes and components and services. So it's basically a kind of Angular 2 approach of which the graphics is layered. I've suppressed in this example the SVG layer and the HTML, CSS3, CSS3D video layers, and what remains is the UI, which is up here. This is fairly self-explanatory and it's all in the README, so I won't bother to do that now. Just all of these layers exist on independent subviews, and the other part of the approach to the problem that I've taken is that I think that particle systems and complex rendering really should be done on the GPU. It would be a waste to do it on the CPU, and it would interfere with the frame rate or the scene complexity. So I've attempted to do it, to do the particle system on the GPU, partly successfully. What I did is take some GPU code and I'll just go to it now. Take some GPU code and modify the dynamic parameter introduction from the declarative code, and also the animation rendering loop, which is partly successful. I just made dilating, increasing diameter spirals starting at random points at the bottom of this sphere. This sphere that you see is actually the camera sphere on which there are lights, and this can be suppressed. I'll just do that. It just makes it easier to see camera rotations and so on. I've made notes about that. It's easy to rotate the system. If I bring back the camera sphere, there's pan and tilt and so on, and rotations and all kinds of camera functions, but that's not important. The important thing here is that this is all controlled declaratively. 16 parameters of which the GUI allows dynamic control, but probably more important in production, you wouldn't want a dynamic control sitting there. So it's possible to actually, the declarative system is an Angular directive, that's the key. And that, I also had to modify this so that the directive is able to include itself in the render loop, so that the particle system update is done in the render loop for the general scene. And then when the scene is dissolved and destroyed, that state causes its render to be destroyed also, and therefore not remaining. And the basic idea is that there's a template. It's an SVG template with a special namespace, XML namespace, that I describe the i3D and the particle system and all kinds of other i3D 3D abstractions that are in directives in the system. And the template, and then the model itself that gives values to the template is a JavaScript object, or you might think of it as a JSON object that delivers the parameters, the initial parameters for the particle system. So I think it's enough said. It's better to view this from a website. I'll include the link there as well. It can be downloaded and played with. Like I said, the the GPU. I need to study the GPU implementation more closely, the vertex shader, to figure out how to get it to be exactly all spirals. But I wanted to get this done today, so probably needs another day or two to really tweak it, but you get the idea. Okay, thanks very much.